Alright, so today we're back to this redox again. In the first few lessons of redox, we have already studied what is the definition for oxidation and reduction. So you basically define redox based on the Ohio theory. Okay, right, so today onwards we'll focus on the second parts of redox, where we will look at one by one of these four reactions that is in your SPM syllabus. Okay, so what are the four chemical reactions that you need to know in redox in your SPM syllabus? So the first type of reaction is about displacement of metal from their salt solution. Okay, the second experiment is, or the second reaction is about displacement of halogen. The third one is the transfer of electron at a distance. And the final reaction that is linked to redox is the conversion of iron 2 ion to iron 3 ion, and the other way around. So we have already covered the displacement of metal previously, so today we'll focus on the displacement of halogen. Now, if you're still wondering what is halogen, let us do a quick recap on what is halogen. So when you look at your periodic table, okay, this group 17, where we have fluorine, chlorine, bromine, iodine, and astatine, they belong to group 17, and in a group, we call them as halogens. So when I say halogens, I'm talking about fluorine, chlorine, bromine, iodine, and astatine. All right, either one of them. Right, so what are the things that we have to know about halogen before we can proceed to today's lesson? Okay, first thing first, we need to know about the colors of some of the halogen, because today I'm only going to focus on chlorine, bromine, and iodine. All right, so first, okay, I'll list down my halogens: chlorine, bromine, iodine. Now they are a bit special because somehow their solution are colored. So we have to jot down what are the colors for each of these solution. All right, so what is the color for their solution? So when I have chlorine water, bromine water, and iodine solution, what color will it be? Okay, chlorine is a very pale greenish yellow color solution. So sometimes you can't even see that, oh, it's colored, because it's just too pale. All right, then bromine and iodine, the color of the solution is very similar. Bromine water and iodine solution, their color is very similar. It's close to yellowish brown, and we will usually just say it is brown in color. All right, so now when bromine and iodine is same color, that means we have a problem to identify each of them from one another. So if I have two test tubes, one is bromine and one is iodine, and I lost label of it, both are same color, how am I supposed to confirm that which is bromine and which is iodine? So what can I do is, there is a chemical that can help me with this, and the chemical is called a tetrachloromethane. Basically means a carbon compound that is attached to 4-chlorine. Okay, tetrachloro means 4-chlorine. Okay, right, or sometimes when your lab is running out of tetrachloromethane, you can have another substitute, and the other substitute is called 1,1,1 trichloroethane. All right, 1,1,1 trichloroethane, and the formula is CH3Cl3. Okay, either one of these will be able to help you identify one halogen from another. All right, the chlorine, when you dissolve in this organic solvent, any one of them, it will appear colorless. Whereas bromine will still remain brown, while iodine will now turn into a purple color. So when you have bromine and iodine that is in front of you and you have lost label, how? Just add them with a bit of tetrachloromethane or 1,1,1-trichloroethane, and you'll be able to see the difference in color. That's how you differentiate them. Alright, okay? Alright, and last but not least, guys, even though halogens are colored, alright, but it's only when they are in the form of element. It's only when they are in the form of element. That means when they are in the compound, for example, I have NaCl, which is a table salt that I eat, right? So salt solution that you make at home, do they have color? They have no color. So remember, when chlorine or bromine or iodine, right, or NaBr, NaI, okay, and also potassium chloride, potassium bromide, and even potassium iodide, all of their compound, okay, this one we generally call them halides. Their solution are all colorless. Okay, remember? So when I have halogen in a compound, their solution are all colorless. Please bear in mind, because at the end of the day, in exam, when they ask me question about this reaction, they will also ask me observation. So I have to be very sensitive with the color change. Alright. Okay, so now, and the last thing that we have to bear in mind is, okay, chlorine, bromine, iodine, okay, going down, it gets less reactive. So that means if I compare the reactivity, chlorine is the most reactive, whereas iodine among the three is the least reactive. Alright, so this is some of the prerequisite for you to proceed for today's lesson. Okay, so please take a minute to copy down or to digest this information before you proceed with the video. Alright, okay, so now let's come back to our main topic today. Our main topic today is to talk about the displacement of halogen from their halide solution. So one example that I have here is chlorine. Okay, chlorine element, chlorine water, reacting with potassium iodide. Alright, so first thing first, I'm going to write a chemical equation for this reaction. Chlorine, Cl2, reacting with potassium iodide, Ki. What will this produce? Alright, so I need to refer back to the reactivity. Chlorine is the most reactive and it is more reactive than iodine. So can chlorine displace iodine? The answer is yes. So chlorine will kick out iodine and iodine come out alone. Alright, forever alone. Okay, then chlorine, after it kick out the iodine, it can form KCl. And as usual, I'll be balancing my equation. Cl2, so here I put a 2. That balance for my Cl, and because I have a 2K here, so I'm going to make 2K, and here 2I2, it's balanced already. Alright, so for this fraction, how do I know whether it's a redox or not a redox? So if you have been following me, you should know that every time we talk about redox, we try to split our species into the ions whenever possible. Right, so what I'm going to do now is for chlorine, I'm going to split. Can I split chlorine? No, you can't, because it's an element, so it will remain as chlorine. Okay, so this one is still chlorine, no changes. For potassium iodide, I'm going to split it to K plus and I minus. Okay, right, and next I have KCl, is also an ionic compound, so I can split it to K plus and Cl minus. Okay, and last one, iodine is an element, so I'm not going to split it. I'm just going to remain it as iodine. Okay, so from here now, what I can see is my chlorine going from no charge, okay, has becoming an ion with charge minus. So it goes from oxidation number 0, right? Chlorine go from oxidation number 0 to oxidation number negative. 0 to -1. Is this an increase or decrease in oxidation number? It is a decrease, 0 to -1, going down. So this is a reduction reaction. Reduction reaction. So chlorine has undergone reduction reaction. Okay, so how do I complete my ionic equation for this reduction reaction? Simple. Cl to Cl minus. And remember, when you complete the equation with electron, electron must be at the more positive side. So in this case, it is this side. Okay, so don't forget chlorine is diatomic, so I'm going to write Cl2. And since just now I have 1 chlorine is 1 electron, so 2 chlorine, 2 electron, and I found 2 chloride. Okay, so in this reaction, when I analyze, I realize, oh, chlorine become negative, so it undergo reduction. All right, reduce. Next, I'm going to look at my potassium. K plus before the reaction. After the reaction is still K plus, so there's no change. I can just ignore it. Okay, I can just ignore it. There's no changes, no oxidation, no reduction. Now look at my iodine. It has gone from I minus to I no charge. So the oxidation number has changes from -1 to 0. Is -1 to 0 an increase or decrease? It is an increase. So increase in oxidation number means it undergoes oxidation. So my iodine is I minus at first. After the reaction, it becomes no charge. Okay, it has become something without charge. So my electron this time round, I'm going to put at my right hand side because this side is more positive. Okay, and since it's a diatomic molecule, so I'm going to top it up with 2 and everything 2. Alright, so for this reaction, I am done writing my ionic equation for oxidation and reduction. Okay, so I'm done. Usually question will ask me to write this down. And sometimes question will also ask me to write overall ionic equation. So how do I write the overall ionic equation? Very simple. Okay, what have we done just now when I write the chemical equation at first? I split them, right? I split them. So after I split, I realize chlorine undergoes some changes. Iodine undergoes some changes. The one that does not undergo changes is potassium, so I've cancelled it. So when you write your overall ionic equation, you just ignore the K plus because it has no changes, so just ignore it. And the rest of the thing, I'm just going to copy back and it will become my overall ionic equation. So how? Chlorine undergo changes, so I'm going to write back my chlorine here, Cl2. After that, K plus does not undergo any changes. I'm not going to do anything. So I'm just going to copy back my I minus. And don't forget, in front of the Ki, there is a 2 here. So by right, I have 2 iodide. 2 iodide. After that, after arrow, the K plus has been cancelled because it has no changes. So I'm not going to do anything on it. And chloride is something that I get from chlorine just now. Right, so 2 Cl minus, I will copy back. And then I have here iodine. So this is very simple how you write overall ion equation. Basically, from your chemical equation, you split everything into ions. Then whichever ion has no changes, you just ignore them. And you copy back the ions that has changes. Okay? Alright, that's all. Okay, now, in this question, I will have some observation. And what is my observation? Now, let's look at this. Imagine when I carry out this experiment in a test tube. Alright, imagine I carried out this experiment at the test tube. So at first, I have Ki, potassium iodide. So at the beginning, does my solution have any color? The answer is no, because we realize that halogens in compound or halides, they are all colorless. Alright, so at the beginning of the reaction, I do not have any color. Right, it's colorless. Then, I will be adding chlorine. Okay, so after I add chlorine, what do I get? Now my product has become, oh, this is a bit disturbing. Let me draw a line between this. Okay, so after I add chlorine to potassium iodide, now what is in my test tube is now KCl and I2, right? KCl and I2, okay? Potassium chloride and iodine. Now, does it have any color? The answer is yes. The answer is yes, because KCl should be colorless, but then iodine should be brown color. So now I know it has turned into a brown solution because of I2. Okay? But then guys, if I tell people this solution is brown, so the halogen present is iodine, people might actually dispute, hey, bromine is also brown. Then how can you just simply say because it's brown is iodine? Because at the same time bromine can also be brown, right? So how you further identify that what is present in here is really iodine? Okay, you are supposed to add, okay, no space already. Okay, so what you can do here is you can now add the tetrachloromethane. Okay, the tetrachloromethane. Okay, the moment you add tetrachloromethane, you will form two layers. You will form two layers, all right? You will form two layers, and the top layer and the bottom layer will have a different color. It will have different color. And what is the color? Okay, very simple. On top, I will form purple color. On top, I will form purple color because the CCl4 has dissolved the iodine. Okay? Whereas the KCl, it does not dissolve in CCl4. When I add CCl4, okay, only the iodine will mix with it, but KCl will not mix with it. That's why I form two layers. Alright? And the top layer is where my iodine is, so it will be purple. And at the bottom layer, my KCl will be there, and KCl has no color. Alright? So for this reaction, okay, what you can see is at first, okay, I have my Ki, it has no color. When I add chlorine, I get KCl and I2 is brown. Okay, in order to further identify that it is really iodine, I add CCl4. So the CCl4 will take the iodine with it, but KCl don't want to join them because they're simply not soluble. So I form two layers. So the layer with purple color has show people that, hey, this purple color really represent iodine. Okay, because only iodine in tetrachloromethane is purple color. Alright, so from here, if they ask me what will be the color of iodine and tetrachloromethane, I'll just write here, it's purple. Alright, okay. So now we are going to look at more example of displacement of halogen from their halide. So let's try this one. Okay, the first one, I have chlorine reacting with KBr, Cl2 plus KBr. So will there be any reaction taking place? Will there be any reaction taking place? The answer is definitely yes, because chlorine is more reactive than bromine. Chlorine is more reactive than bromine, so I'm going to get KCl and bromine. Okay? Alright? So, at the end of the day, when I add CCl to the solution, okay, CCl4 to the solution, what is the color? CCl4 in bromine, I will see brown layer. Okay? Right, next, chlorine reacting with potassium iodide. Okay, I'm supposed to get KCl and iodine. Since the ending reaction, the halogen I get is iodine, so in tetrachloromethane, it's going to show purple color. Oh, I didn't balance the equation. Okay, right. Then next, look at the the third reaction that I have. Bromine with KCl. Now, for this reaction, actually nothing changes. Nothing changes. Why? Bromine is less reactive than chlorine. If you check again the reactivity, so there will be no reaction. Okay? No reaction means my product will still be bromine and KCl. So if I add a CCl4 in there, the bromine will show brown color. Okay? Right. Next up, I try to pair bromine with potassium iodide, will there be any reaction? Yes, because bromine higher than iodine, more reactive than iodine. So I will be getting a KBr and iodine. And since I end up getting iodine, so in tetrachloromethane, it will be purple color. Okay, and last one, iodine reacting with KCl and iodine reacting with KBr. For your information, these two reactions will not work because iodine less reactive than chlorine and also less reactive than bromine. So end up, I get back whatever is my reactant. That means I don't get any new product. Okay, so since at the end of the day, my product is still iodine, so in the organic layer, it will be purple color. Alright? Okay, so that's all for this lesson about displacement of halogen from its halide. If you have any question, please do not hesitate to DM me, okay? Right. Thank you.